A number of you seem to be struggling with some of the concepts within Lesson 6.2, which has to do with inverse functions. You need to remember that inverse functions are functions that undo each other. Much like in algebra, we use addition to undo subtraction, or we use division to undo multiplication. We use sine and arcsine to undo each other, as well as cosine and arccosine to undo each other, and tangent and arctangent. Now, while there are cotangent and arccotangent, secant and arcsecant, your typical calculator only has the three basic ones. So if you look at your face of the TI-84 calculator, you have the buttons sine, cosine, and tangent. You also have above them in blue, which is a second function, sine to the -1, which is the symbol for arcsine. You have arccosine and arctangent. So one of the things you want to do when you're working through problems where you need to use the inverse trigonometric function is you want to try to put the question in terms of either sine, cosine, or tangent. Now, typically, when you're working with the arc functions like arcsine, arccosine, and arctangent, we typically do that in terms of radians. However, I did notice within Newton that some of the questions ask you for the response or the answer in terms of degrees. For example, this question on the screen says, use a calculator to solve the following equation for theta on the interval 0 degrees to 180 degrees. So you're going to have to be very careful, read the question completely, pay attention, because you have to be sure your calculator is in the right mode in order to get the right answer. So, for example, on this question, it's wanted the answer in degrees. So I pressed the mode button and I scroll down to the line that says radian and degree, and I'm going to toggle over to degree and hit enter. And now degree is blinking. So now I have the calculator in degree mode. So a couple other things that I want to mention to you. First of all, notice that this particular function is the cotangent of theta equals 3.62. Okay, so again, to undo that, we could use the arc cotangent, but I don't have that option on the calculator. So because of the fact that we want to use the calculator, I need to rewrite this problem in terms of either sine, cosine, or tangent. Now, in my mind, the one that I'm going to use, and that may be part of the challenge is knowing which one to use, is to do tangent, because I can use the reciprocal identity. We know that cotangent of an angle is 1 over the tangent of the angle. So I can rewrite this so that I have the tangent of theta is 1 over the cotangent of theta. And in this case, I know that the cotangent of theta is 1 over 3.62. So I'm going to do the reciprocal. Then, once I have it in terms of the tangent, I can use the arc function, the arctangent, and I'm going to take the arctangent of both sides just like I would add or subtract something from both sides of an equation. Again, what that accomplishes for me is that the arctangent and the tangent are inverses. They cancel one another off, and I'm left with theta equals the arctangent of 1 over 3.62. At that point, I can enter that expression into my calculator, basically just as I see it. Again, making sure that my calculator is in degree mode because I was asked for an answer in terms of degrees. Okay, so let's get out of this. And so I'm going to enter what I had. I have the arctangent of 1 divided by 3.62, close the parentheses and hit enter. And it gives me a value of 15.4424466. So it was asking for 1 decimal place. So I would say that theta is 15.4 degrees. So the cotangent of 3.62, theta, is an angle measure of 15.4 degrees. Now, guys, that's a lot to think about, okay? So, but you got to try to put all of this and process it all together. Okay, so here's the next one. It says use a calculator to solve the equation for theta on the interval from negative pi halves to pi halves. Okay, so again, because it's in the, we want to use a calculator, we want to rewrite in terms of sine, cosine, or tangent. And honestly, the best identity to use in order to do that is going to be the reciprocal identity. So cosecant of theta is 1 over sine theta, or vice versa. Sine theta is 1 over cosecant theta. Okay, so that looks a little messy here, and we can simplify it. So let me walk you through it. So I would have the sine of theta equals 1 divided by negative 8/5. Okay, so since this is a fraction, I'm going to come off over here to the side and do some scratch work. 1 divided by negative 8/5. Remember, to divide fractions, we flip and multiply. So we're going to have 1 times negative 5/8, which gives me negative 5/8. So this simplifies to the sine of theta is negative 5/8. So again, at that point, using the reciprocal identity, I have the answer, or have the question rewritten in terms of sine. Now, one other thing I want us to think about here is, notice this interval, okay? That interval, if you think about it in terms of your coordinate grid, okay, it goes from negative pi halves to pi halves. So remember, you have 0, and then straight up is pi halves. If you keep rotating, you'd have pi, 3 pi halves, and 2 pi. So you may think, well, where does negative pi halves come from? Remember, if we rotate negatively, negative 3 pi halves is the same thing, or excuse me, negative pi halves is the same thing as positive 3 pi halves. So when you think about the interval, or where your answer should be here, okay, your answer has to be somewhere between here and here. So it's either going to be in quadrant 1 or it's going to be in quadrant 4. Well, if we think about it, the sine, which corresponds to the y value, is negative in quadrant 4. So I know that I should get an answer somewhere here in quadrant 4. And that may help you out too, especially if the test or the question is multiple choice. Okay, so then to undo sine, we use the arc sine. Again, the point of using the arc sign is that the arc sign and sine will cancel one another off. So I have theta equals the arc sine of negative 5/8. Now, it may not be as obvious with this question, but with this question, your answer should be in radians. And I know that because it gave me the measurements negative pi halves to pi halves. When it's stated in terms of pi, that gives me radians. I also think in Newton, the answer blank indicates you want radians. So the first thing I have to do is on my calculator, I have to switch the mode to radians. So you may have to toggle between radians and degrees. You're going to have to pay very close attention to how the question is asked. Okay, so now I'm in radian mode and I want to do the arc sine of negative 5/8, close the parentheses, and enter. And I get negative 0.675131532.9. Again, I think it asks for 3 decimal places, so our answer would be theta is negative 0.675 radians. Okay, so you have to be careful. Let's do one more. Actually, this switches to a different question. Okay, this one says evaluate the following expression. Report your answer as a simplified fraction. Okay, a couple of things here. The wording of this question when it says evaluate and then it wants your answer as a simplified fraction, that is a big clue that I'm probably going to use the unit circle. And I should come up with one of the values on the unit circle. So this question, it says we want to find the arc sine of 3 square root of 3 over 2. So the question really is where on the unit circle does the sine equal square root 3 over 2? But now you have to be careful because the arc sine is only defined between negative pi halves and positive pi halves. If you're looking at the unit circle, okay, you have pi halves and you have negative pi halves. Of course, zeros in between. So arc sine is only defined between pi halves and negative pi halves, which again is either quadrant 1 or quadrant 4. Okay, so you have to be careful. That is in the definition of arc sine. It is defined, and it's defined that way so that the function is 1-to-1 and has an inverse. So really, when I see this expression, arc sine of square root 3 over 2, I'm thinking, where on the unit circle does the sine equal square root 3 over 2? So I don't have my unit circle pulled up, so I'm going to kind of think through it in my head here. Okay, it's positive, and the sine's going to be positive in quadrant 1, and I would go square root 3 over 2. Okay, I believe that's going to correspond to pi thirds. If you go and look at your unit circle, I believe that is 1/2 comma square root 3 over 2. Okay, this is just kind of a logically reasoning it out looking at your unit circle. So the answer here, the arc sine of the square root 3 over 2 is going to be pi thirds because the sine has the value of square root 3 over 2 at pi thirds. And that's how you have to enter it into the computer. It wants it written as pi over 3, a simplified fraction. Okay, you'll have access to your unit circle for the final exam while you're working on your homeworks. Okay, so make use of it. Again, this question says evaluate. Report your answer as a simplified fraction. Again, when I see that phrase, I'm thinking, okay, I'm going to use the unit circle. And the question is the arc cosine of 0. Okay, so again, that's really asking me where on the unit circle is the cosine equal to 0. Now, here again, you have to think about your unit circle, okay, and the cosine function. Cosine, or the arc cosine, by definition, is defined between 0 and pi. Okay, so arc cosine, by definition, is defined between 0 and pi. Okay, so your answer is either going to be in quadrant 1 or quadrant 2. So I'm looking for where is the cosine equal to 0. And I believe, again, I don't have my unit circle pulled up, but I believe at pi halves we would have 0, 1. So the arc cosine of 0 would be pi halves. Okay, it's important, and you may want to write these down, that you realize that I'll make you a little summary here, for your arc functions, that arc sine is defined between negative pi halves and pi halves, which means it's either quadrant 1 or quadrant 4. Arc cosine, as I just mentioned, is defined between 0 and pi. So it's either quadrant 1 or quadrant 2. And we're going to look at an example of arctangent in just a minute. Arctangent is also defined between negative pi halves and positive pi halves. So your answer will either be quadrant 1 or quadrant 4. Okay, that's some important information. And if your answer is outside that range of values, then it is not correct. Okay, so let's look at this third one. Again, it says evaluate the following expression. Okay, and write your answer as a simplified fraction, again, which is my clue that I'm going to use the unit circle. Okay, it doesn't specifically say that. Whereas for the calculator problems, notice it did say use a calculator. Okay, so this one would be where on the unit circle is the tangent equal to the square root of 3. Now, that's a little bit harder to do because you can't just read the ordered pairs. You have to think about it. Okay, so again, some information that you may find helpful to write down is you may want to kind of get familiar with the tangent of pi sixth, the tangent of pi fourths, and the tangent of pi thirds. That may help you if you kind of memorize or know those. The tangent of pi fourths is 1. The tangent, remember it's sine over cosine, so I'm doing them in my head. Let's see, the tangent of pi sixth would be square root 3 over 3, and the tangent of pi thirds is square root of 3. So those may be 3 that it's worth memorizing. Okay, so again, if I'm thinking about it and I know that the arctangent is defined between negative pi halves, or excuse me, positive pi halves and negative pi halves. Okay, so I'm somewhere either in quadrant 1, I'm somewhere between quadrant 1 and quadrant 4. And I know that the tangent at pi thirds, okay, so again, if you're thinking about your unit circle, okay, pi thirds, which has the ordered pair square root 3 over 2 comma 1/2. Okay, oops, sorry, I got that backwards. Oops, my fault. Got my ordered pair backwards. Sorry. Okay, so 1/2 square root 3 over 2, okay, gives me square root 3. So my answer, the arc tangent of square root 3 is positive pi thirds. Again, where on the unit circle is the tangent square root of 3? Again, it's a little bit trickier because you can't just read it right off the unit circle. I would encourage you to memorize those three values there in blue. All right, then it goes back to using a calculator, okay? If it gives you something, so this one again says use a calculator to solve the following equation in the interval, and notice that the interval is in degrees, so your answer should be in degrees. This one already is in terms of tangent, so that's nice. I don't have to rewrite it, okay? So we have the problem tangent of theta equals -4/3. So to undo that, okay, I'm going to use the arc tangent. Again, what that does for me, how that helps me, is remember arc tangent and tangent are going to cancel each other off. So I have theta equals the arc tangent of -4/3. So I'm going out to my calculator. Again, because of the interval that's given in degrees, I need to have my calculator in degree mode. So I press mode, arrow down, highlight the word degree, and enter. And then I can type in my expression. I need I forgot what it was, the arc tangent. Okay, so second tangent of -4 divide 3. Okay, I think I entered that correctly. Yes, I did. Okay, and then we enter. And it tells us 53.130102335. It asks us to round to one place. So our answer here would be that theta is -53.1 degrees. Now in Newton, you don't have to enter the degree symbol. You do have to indicate that this is a negative angle. Okay, so be careful. All right, here's another one. Use a calculator to solve the following. Again, it tells us to do it with a calculator. And if I remember correctly, this one was on the interval from -pi/2 to pi/2, which is an indication that I'm going to use radians, okay, because it has the pi's in there. So we have our equation, sine of theta equals -5/6. To undo the sine, we use the arc sine. So I have arc sine. Take arc sine of both sides. That helps me because arc sine and sine will cancel one another off. So we have theta equals the arc sine of -5/6. Again, be careful when you go to your calculator because you need to have it in radian mode. So I have mode. I'm going to arrow down, highlight radian, and enter. Then we can do arc sine of -5/6. negative 5, divide 6, close it, and enter. And we get negative 0.9851107.833. It asks for 3 decimal places. So we're going to say theta equals negative 0.985 radians. Okay, I hope you find this video helpful and it gives you a better explanation of using the arc functions or the inverse functions of trigonometric functions.